So for number 25, I do want to draw these curves and see the area between them. So let's begin with drawing our square root of x. We'll just draw our axis, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, and so on. So for our first curve, it goes 0, 0, 1, 1, 1, 2, 3, 4, 4, 2, and then 9, 3. So it is a curve that goes something like so. This is y is equal to square root of x. Now we have to draw our second line, which is the line x is equal to 9. So it's a line that goes over here. Let me just move this up. Yeah, this is x is equal to 9. And now lastly, we do have to draw our y is equal to half times x. So this is just a straight line that passes through the origin. So it goes, let's see, 2, 1, and then that should go 4, 2. Yeah, so it goes something like here, and it should keep going upwards like this. Yeah, and this is the line y is equal to 1/2 x. Now we can see that there are two segments of area between these curves. The first segment is this one that is in yellow, and the second segment is we'll draw this one in pink over here. Now we do have to break this up into two different integrals because in this segment over here, the purple curve is the upper boundary and the green curve is the lower, whereas for this one over here, the green curve is the upper and the purple is the lower. So we do have to break this up into two integrals. And before we can do it, we just have to find exactly where they intersect so that we have our boundaries of integration. So we have square root of x is equal to 1/2 x. So let's square both sides. So then we have x is equal to x squared over 4. And then let us bring the x over to the right-hand side and multiply everything by 4. So first I'm going to multiply everything by 4 to make it easier. So then this becomes 4x. And now let's bring everything over to the right-hand side. So 0 is equal to x squared minus 4x. So if we factor out an x, this goes 0 is equal to x times x minus 4. So we can see that their boundaries are, let's draw this in a different color, the point 0 over here, the point 4, and lastly at 9, right, defined by this line. Okay, so once we have this, we are ready to set up our integral. So integrals, because it's multiple. The first one is the integral from 0 to 4, which were our boundaries of the upper curve is square root of x minus 1/2 x, and all of this times dx. And then we do have plus the second integral, which goes from 4 to 9 of the upper curve, which is 1/2 x minus square root of x, all of this times dx. So let's integrate it. It's pretty simple with just the reverse power rule. So this is x times 2 over 3. I meant 3 over 2. X times 3 over 2 times 2/3 minus, this is x squared over 2. So that gives us minus x squared over 4 from 0 to 4. And then plus, this is x squared over 4, x squared over 4 minus 2/3 x 3/2 from 4 to 9. So now all we have to do is plug in our boundaries. So let's calculate it. 4 to the power of 1.5 is 8 times 2, so that is 16 over 3 minus 4 squared to 16 over 4 is just 4, minus 4. And then we don't need to plug in the lower boundaries because the lower boundaries will just give us 0, right? And then plus, let's look at this other side. So in the upper boundaries, this is 81 over 4. 81 over 4 minus, let's plug in 9 over here, minus 81 over 4 minus 54 over 3, and then minus the lower boundary, so minus 4 squared over 4, minus 4, and then minus minus, so plus minus minus, and then that becomes, let's see, 16 over 3 when we plug it in. So all that's missing is for us to finally calculate this. So this is 16 over 3 times 2 minus 8 minus 54 divided by 3 plus 81 divided by 4. This should give us 59 over 12. And that is the area between these two curves when we break up the integrals into two, and then we evaluate the boundaries.